Terrific, and thank you. It was so very kind of you. Um, and on a topic like this, the future of our labour market, it's terrific to see so many young people here because it's your labour market that I'm talking about. And those of us of my age are just hoping to get through the rest of our careers without computers and robots taking our jobs. So what I want to do, here's the roadmap for today. We want to talk about the economics of AI. So I'm going to start with the microeconomics of AI and ask how it's going to change our work and whose work it will change. Then we'll move to the macroeconomics and ask what sort of big picture effect is it going to have on things like how much money we make, how much stuff we produce. Then we'll turn to political economy. This is a polite word for politics, which is AI is going to upend an enormous amount within our labour market, and it's going to create distributional conflicts, and it's, I think, important to understand where and how those come from. And then I made up a new word. If we're going to go from microeconomics to macroeconomics, I want to talk about how this affects you, so I'm going to call that Me-conomics. How can you adapt to the changes that are coming in your careers? So let's start with the microeconomics of AI. And the first question is, how is this changing the workplace? And so I want to begin with 3 business case studies. The first of these is a study where what they did is they recruited professional freelance coders. They gave them each a very simple task. The task was to implement an HTTP server in JavaScript. In this case, the group who got tails, they were told to just go and code it the way you normally would. And so they used the same sort of internet resources that any of you in this room who code would normally use. The other group were given access to an AI assistant called GitHub Pilot. At the time, it hadn't yet been released to the public. And what you see here is that among the control group, they took a little bit over 2 hours to complete this task. But among the treatment group, who'd only had 1 minute of training in using this new tool, they were able to get this fairly straightforward coding task done 56% faster in a mere 71 minutes. So that suggests there may be massive gains for at least some people from using AI. Let's take another case study. This case study went to a bunch of office workers, and it gave them professional writing skills of the type that many of us in this room would normally do. Those of us who have white-collar jobs, often we have to write a press release or a short memo or write a delicate email to someone whose performance may not be up to snuff. And here what they did was the control group, once again, was told to use their regular work, whatever that is. And the treatment group was told before the task that they had to sign up to chatgpt and that they were welcome to use chatgpt while performing this task. It's a fairly straightforward task. The people in this experiment were people like you and I. They were white-collar workers, college-educated professionals. And the average time among the control group to complete this straightforward writing task was 27 minutes. But among those given access to chatgpt, it was 16 minutes, so it was 40% faster. In addition, the quality of their work was in fact somewhat better. The third business case study I want to give you comes from a Fortune 500 software firm. This now is not an experiment in the lab. This is actually real people doing their jobs every day. This is a software firm where they have a help desk. You would call it a call center normally, except people don't call, they do the online chats instead. And here the control group was again told to just continue doing the work that they would normally do when a customer comes in asking for technical support. The treatment group were given access to a new chat assistant. Basically, they would continue doing their work, and the computer would monitor what they were doing and offer them suggestions for how they might respond if they wanted to. The person was still in charge of their own work. They could reject the suggestion, they could do what they normally wanted to do, or if they thought it was a good suggestion, for instance, the computer might say, "I'm sorry that you're struggling with that problem, let's try and troubleshoot it." They could say that instead. And what we see here is that they were able to close customer support tickets 14% faster. So hopefully these 3 case studies, which are real experiments, show that this new treatment, this new way of doing work is remarkably more efficient. And what I've shown you is that people tend to do more work. What I haven't shown you is there's also findings in all of this literature that they're doing higher quality work. One of the really fun things about this study of the customer support staff is, when you talk to customer service and you're getting really bad customer service, sometimes you'll say, "May I speak to your supervisor?" It turns out that the people in the treatment group using the AI assistant, they were less likely to have that happen. So they were not only treating more customers, it seems that they were treating them better as well. So what we learn from this is a technology that has the capacity in the few domains in which it's been scientifically studied to make us all dramatically more efficient. And you might say, well, that's the way of the world. We've been enjoying technological change ever since the Industrial Revolution, or even before it. Wasn't the steam engine terrific, and electrification and the invention of computers? And yes, all of those were wonderful technologies. What's different about this technology, well, what's the same about this technology, is it's going to transform the labor market. What's different about this technology is who it's going to affect. These previous technologies have all basically substituted for physical labor, blue-collar work. What's different this time is, this is a machine of the mind. It shapes cognitive work. So just as you saw automation fundamentally transform the labor market for blue-collar workers, let's fast forward. We're going to see AI transform the labor market for white-collar workers this time. And so that makes it fundamentally different than any of our more recent technological revolutions. Okay, so we know what it does. This idea that it affects cognitive work, this gives us something of a sense of who it's going to affect. Let's dig into that a little deeper. Here, what I'm trying to do is think about the range of all the jobs that exist in either the Korean or the American economy. There are some jobs where AI is going to have effectively no impact. AI can't automate any of the tasks. Think about a professional athlete. Think about a cook or a dishwasher or a floor layer or a meat packer. None of these folks are going to have their jobs at all affected by AI. At the opposite extreme, there are jobs where your tasks, what you actually do minute to minute, are pretty much the tasks that AI is doing faster, cheaper, and at higher quality. I think the obvious example of this, and apologies to whoever is in this room translating me right now, is translation. Computers are now unbelievably good at this and incredibly cheap. But it's not just that, right? Copy editors are the same. If any time you're doing written work, put it into the computer and you'll get something better coming out. You can think about other things where it's about taking large bodies of knowledge and summarizing it. So financial analysts, tax preparers, and so on. So those are the extremes. Where does the workforce in industrialized countries lie? So 80% of American workers are in occupations in which at least 1/10 of their tasks could be automated by AI. So that says that AI is going to touch almost all of our lives. 50% are in occupations where AI could effectively do at least half of your job. And these are the folks who need to worry that maybe the computer is coming for their jobs. And so as a result of this, and the nature of this, that it's a cognitive set of tasks that it's taking over, it's going to have very uneven effects across sectors. And you can think about exactly where you would expect it to be. Think about the legal profession. Paralegals often have to read through and organize boxes of documents. Well, AI is extraordinarily good at that. And so that's a sector that is being transformed as we speak. At the other end, building, cleaning, and maintenance is something that AI is not particularly useful for. And so that's a sector where AI is not going to have a big effect. So that's the microeconomics. What is AI going to do? It's going to make some of us enormously more productive. And the question is, who of us or which tasks? And it's the cognitively focused tasks. And what I want to do now is move to the macroeconomics of AI. What can we do with what we've just learned to see what the broader effects on the economy are? And one way of thinking about this is to think about the macroeconomy, the entire economy, as simply being a collection of tasks. So it's not that I'm an economist It's that right now I am a speaker. I am speaking. That's my task. And this morning my task was analyzing data and so on. And so if you take a view like this, one estimate suggests that AI could transform 20% of all tasks, right? AI is not going to be a very good cook, but it is going to be an excellent translator. By the way, let me be clear. What I'm about to do is I'm going to give you a straightforward accounting right now of the likely macro consequences. And it's going to suggest they're pretty small. And then I'm going to give you a more optimistic accounting because economists love on the one hand, on the other, where I'm going to suggest it could be quite a lot larger. But I wanted to start with the very simple arithmetic of this first. I hope it's not too early in the morning to do math because we're about to do math. So if 20% of all jobs could be transformed, one estimate is that only 23% of those jobs, those tasks, could be automated in a way that's cost effective. This comes from looking at past efforts at automation. Just because something can be done doesn't make it cost effective. So that says that 4.6% of all tasks will be done by AI. Now, if you automate a task, one estimate suggests that that would yield a 27% labor saving. So that then means if we automate 4.6% of all tasks, we'll save 1.2% in labor costs. Now, labor is only 53% of all costs in the economy. So now this says that if we implement AI, this estimate suggests we'll get a 0.66% reduction in production costs. Let me say it another way. That's the same as saying we will get a 0.66% rise in productivity. Let me be clear about what this means. This isn't saying productivity growth will be 0.6 percentage points higher every year. This is actually a forecast that says over a decade, it will only be 0.6 percentage points higher. That's barely enough to notice. I want to be clear, this is not my forecast. This is from Doron Ajamoglu at MIT. Now, this is just a productivity boost. Now, that's not the whole story, because in order to implement AI to take over those 4.6% of all tasks, we'll need to invest in AI. And so we'll need a proportionate increase in the capital stock. The word we use for that is capital deepening, but it's just the investment that businesses are going to have to do in AI. And so if we need the capital stock to be 0.66% larger and the capital output ratio 0.73, that adds a little bit more to the total effect. And that suggests, all told, that over a decade, GDP, which is the measure of average output, but also total income, will only be 1.1% higher. That's the Ajamoglu estimate. Now, you might think we've figured everything out. Permit me for a moment to get a little more optimistic instead. The first change I'm going to make is, instead of saying only 20% of tasks are automatable, let's say 25%. That's not really a big deal. But now I'm going to show you the estimate that comes from Goldman Sachs. Now, the claim that only 23% of these possibilities are worth investing in arises because you think that automating tasks is expensive. And in fact, ChatGPT was very expensive when it was first launched. But the price that they charge now, it falls roughly 50% every 6 to 12 months. The price of the computing power needed is plummeting at an incredible rate. So maybe this suggests that all of these tasks can be cost effectively automated. Now, remember I said the Ajamoglu estimate said that anytime you automate a task, you'll get a 27% labor saving. But I showed you a bunch of case studies at the start that were even a lot higher than that. So if you took the average of those case studies, you'd say that automating a task would yield a 36% labor saving. It's still true labor only accounts for 53% of the cost, but that now moves from a small impact on productivity. In the previous slide, it was 0.66% to 4.7% over a decade. This now is getting kind of interesting. And then remember, if what we want to do is invest enough to take advantage of those opportunities, that means we'll have to have even more investment in AI. So the capital deepening channel, now instead of raising the capital stock by 0.66%, we'll need to raise it by 4.7%. So once you add that channel on as well, now we're talking about AI raising the level of GDP by about 8% over the next decade. That's kind of interesting. It's not transformative, But gee, it's kind of worth thinking about as well. That's where we're at so far. Let's go further into the macroeconomics. And what I want to do is ask what's missing from my analysis so far, because this is where the optimism might really lie. I've given you sort of a straightforward, almost an accountant's way of thinking about things. But we economists are a little more creative than that. So the first thing to notice is that everything I've been talking about so far have been the cost savings from having AI displace workers. So we've only been talking about the effects on the set of tasks that get displaced. But remember, that's a very small share of all tasks. So there's a lot of people, hopefully all of us, you and I, who are still going to have our jobs. If we still have our jobs and we have access to AI, we're going to be incredible at what we do. And so that's a large part of the population who might get quite a bit more productive because we use AI in our work. For instance, I used it as I was putting this slide deck together. It was a little bit more efficient. So we have some fairly careful studies of what happens when firms adopt AI, and the workers that they keep on and the work they keep doing, the part we've been ignoring so far, become quite a bit more productive over the next few years. And so it's not just about those who are replaced, but also it's about supercharging those who remain. And that's another really important thing. The second thing that we've left out so far is that when you have a transformative technology, the economy itself transforms. I don't have a really good way of making this point, but let's look at what the last 80 years has done to the structure of work in the United States. We reallocate workers from unproductive tasks to more productive tasks. And so when I look at employment by occupation from 1940 through to the present, a lot of occupations shrank. For instance, farming shrank. Now that's actually because farming became incredibly productive. As we invented the machinery to do the work on the land, we need fewer farmers. We saw a lot of laborers and the like. Those occupations became less important because of mechanization in factories and so on. So some occupations will likely shrink as a result of AI. Over the past 80 years, we saw a lot of occupations grow, and here you see the rise of the managerial class, the rise of white-collar work, the rise of cognitive work, if you like. And the other thing that tends to happen is that new occupations get added, right? So it is absolutely true that the word processor transformed the office. It means many fewer typists, but many more software engineers. And so you see new occupations emerge, which are complementary to or go with the new technology. And so much as this happened as a result of the rise of computers and automation, I'm not sure exactly which occupations are going to emerge, but new occupations will emerge in the new economy that the young folks in this room are going to eventually be working in. So that's the second thing we've left out so far, is this just reorganization of work. Let me tell you about the thing that, if you really want to get excited, if you really want to get an economist excited, you talk about innovation. Because at the end of the day, the thing that drives economic growth more than anything else is innovation. New ideas, new ways of doing work. There was a time when silicon was only ever used to build sandcastles. And then we discovered a way of using silicon to make computer chips. That's a transformative new idea. And all of our economic growth is fueled by new ideas. So what if AI can simply make our researchers more productive, our scientists, our innovators more productive? So even if we could only make our innovators 20% more productive, that would raise the rate of productivity growth and hence economic growth by 20%. So if economic growth was normally 2%, it would rise to 2.4%. You might say, well, that sounds kind of dull from 2 to 2.4, but the thing about effects on growth rates is they compound. And 30 or 40 years later, you end up with GDP being 30 or 40% bigger. And so if AI turns out to be a good innovator or a good scientist, or it helps us become good innovators or good scientists, then there could be truly transformative effects on output. So it's those extra effects that then lead to, remember we started with the sort of pessimistic arithmetic of AI, that it would only raise GDP by 1% in a decade's time. But if you think about these other effects, here we have estimates from PricewaterhouseCoopers, Goldman Sachs, McKinsey, Accenture, and JP Morgan. And you're starting to see a similar story, which is here we've got expectations that in a decade, AI will raise output by roughly on the order of 12% on average across these estimates. Look, this is something where I don't think it's worth being particularly precise about. The question is, will AI raise output by 1%, 10%, or 100%? And here it feels like the answer is going to be something close to 10% in a decade's time, maybe far more in the decades after that. Now, maybe this is the sort of optimistic view that within 10 years we'll see quite substantial economic growth as a result of AI. Let me take a step back though and share with you something a little more pessimistic. What we know from past major disruptive innovations is that they often don't have much of an effect, positive effect on the economy that you can see for years and sometimes decades. That's because when you have a new technology, it's not enough just to have the new technology. It will only yield its full potential once you've reorganized the way we do work, once you've reorganized business processes, once you've reorganized your organization. And our organizations are often slow to change. So the invention of the steam engine in 1769 really kicked off the Industrial Revolution, but we didn't see a rise in productivity growth for 60 years. We saw stagnating wages. And the reason for that is we had to reorganize how we do work in order to take advantage of this transformative technology. Electrification didn't yield a large rise in output for another 30 years. And that's because we needed to change our factory layouts so that we could take advantage of the new power or energy that could come to us through electricity lines. For many of the last 30 years, there was this puzzle. We had the invention of the PC. And it led the great Robert Solow, who won the Nobel Prize in Economics, to say that one can see the computer age everywhere except in the productivity statistics. And eventually we did see a rise in productivity, probably through the 1990s. And so that says the PC ultimately changed how we do work, but it took a 15-year lag. And so one of the big questions is, how long will it take for us to readjust the ways in which we do work to take advantage of AI? And one view is maybe AI is going to be really easy. So software is not physical. It's just bits and bytes. You don't need to reorganize the factory. You just need to download it or click on the right website. The way we organize software now is through APIs, which are modular and connective and mean you can change one part without breaking everything else. And the amazing thing about AI is that we can talk to it using natural language. You don't need to learn Fortran or C++, you can speak to it in English, and that may speed adoption. There are still barriers which might slow things down. There's obviously a chip shortage right now. There's the possibility of energy bottlenecks. And as we talk about political economy in just a moment, there's the possibility of regulation as people who are worried about this new future are going to work to slow it down. So the big question is, when will AI change our lives? I think that's a much harder question than will AI change our lives. And if you want to be really pessimistic, you would say, well, look at where we're at right now. 3.9% of American businesses by late 2023 had adopted AI. So that's a very, very slow rate of adoption. Now, a lot of talking about it, and if you listen to an earnings call of any Fortune 500 company, they're all talking about it. But this suggests there's still a lot of businesses that aren't thinking about the tremendous gains that they could make from adopting these new technologies. So as you think about the effect of AI on our economy, I've tried to give you a way of thinking about, a systematic way of thinking about the consequences. But I also just want to admit, and I think warn you, that the stories one hears differ according to who one talks to. So here I've made up an axis. You could think about AI as being just another innovation, all the way through to it's got to transform everything. And I think as a rough generalization, when you talk to economists, we're kind of excited about it. But we also thought the internet was cool, and we thought PCs were cool, and we thought that indoor plumbing was cool. And we thought that light bulbs are magnificent, right? They allow you to do work at night. So we thought lots of innovations have been pretty cool, and this is another one that's pretty cool. But if you talk to people from Silicon Valley, the technologists, they're going to give you these utterly excited views about the world. I'm not here to tell you who's right. I do know that if you're interested in the question of how will AI transform the economy, you should probably talk to some AI folks and probably talk to some economists. But this will at least give you a lens for interpreting what you hear. Okay, let's move from the macroeconomics of AI to the political economy of AI. My goal here is not to jam your head with facts, but rather to give you some systematic ways of thinking about these problems. And this I find tremendously helpful. So imagine you're going to work every day, and then for Christmas, your partner gives you a robot. The robot can do everything your boss asks you to do. What a wonderful Christmas present. So every day, you just send your robot off to work and stay at home. You do more fun things. You go for a swim, you run, you see friends. So as you think about this robot, of course, this robot that your partner gave you, I'm really thinking about AI. Are you better off as a result of this? Absolutely. You're seeing your friends. Is your boss better off? No, but are they worse off? No. The work's getting done either way, right? I want to take the exact same story, but instead of your partner giving you the robot, they give it to your boss. So now your boss owns a robot that can do your job. Same robot. What's the boss going to do to you? Fire you. So now, are you better off? Absolutely not. You just lost your job to this robot that for some reason your partner gave to the boss. Is your boss better off? Absolutely, because they're getting all the work done, but they don't have to pay you a wage. Once you notice this changes how I see things. The problem is no longer the robot. We don't have a robot problem. We don't have an AI problem. We have an ownership problem. The only thing that changes between the happy scenario and the sad scenario is who owns the robot. And I think the same goes for thinking about AI. Let's complicate it a little. Now we'll move to talking about AI. Imagine that there are many competitors who each sell AI models that you could use at work. OpenAI does, Google does, Facebook, and so on. And because the price of computing is so cheap, they sell it for almost $0. What's going to happen is your boss will buy that and fire you. And your boss will buy it for like 1 penny because it's so cheap and fire you. So are you better off? No, you're worse off. Is your boss better off? Absolutely, because they're able to buy your services for virtually $0 because that's the price of AI in a competitive market. Now, let's complicate it one more way. What if instead of there being many firms that compete to provide AI services, there's a monopoly? OpenAI is the only group in town that does it. So now they could sell your boss an AI. Say your boss pays you $500 a week. What they'll do is they'll figure, well, I could sell this to your boss for $499 a week, and your boss will buy it. So now what's going to happen is your boss is not... are you going to be better off? No. Your boss will buy the robot for $499, and you get fired. Is your boss better off? Your boss is $1 better off. Like, who cares? Is the monopolist better off? Absolutely. They're selling a product that costs them almost nothing for $500 each. This now says that we don't have a robot problem, we have a competition problem. And I think this is really, really important if we think about dividing the spoils from this forthcoming technological revolution. And you don't have to work too hard to realize it's not just a problem if it's OpenAI that becomes the monopoly provider, but if what happens is OpenAI needs to buy chips from NVIDIA and it's the only company that sells chips, then all of a sudden you're going to get the same sorts of problems, but it's going to be NVIDIA that gets rich rather than OpenAI. So competition policy is going to be really, really important. Let's move to thinking about your life and your career. We've covered a lot of territory. How do we try and make this directly useful for you? And I'm just going to apologize. Many of you have quite a lot of experience with this, and I'm going to pitch this much more at the level of those of us who are new to trying to think through these issues. So when people first try out AI at their jobs, maybe you're at work and your boss says, write a memo, and you go over to the chatgpt window and tell chatgpt to write the memo. I hear two different reactions. The first one is, this can do my job. The second reaction is completely different. It's, this can do my job. Oh, they sound similar. Sorry, let me go again. The first is, this can do my job. The second is, this can do my job. Both are true. One's exhilarating and the other is terrifying. And then what I want you to do is move beyond this sharp dichotomy and realize that the best answer is, working together, this can help me do a better job, right? So the idea here is an old one in economics. Any technology, including AI, can either be a substitute for you and your work, and if it's a substitute, it will displace you, or it can be a complement, which is something that makes you smarter, more productive, faster. And so the obvious advice at this point is, you want to try and make it so that your skills are complementary to AI rather than easily substituted by AI. So that's, I think, the most important challenge to keep in mind. As you do that, you'll need to think about, what does that mean? And so I want you to understand the opportunity here. We're moved from a world rich with computer code. Computers we've had for decades now. Computers can take explicit instructions to transform inputs into outputs. The problem with computers is the task must be written in code, which means the task must be codified. This is only useful for codified knowledge. We're now in a world with AI. With AI, it infers the instructions from a lot of examples. Think about handwriting recognition. You don't tell it this curly loop and that curly loop make this particular character. You just let it look at lots and lots of characters and let it train itself. That's what a neural network does. And so because it can infer instructions, it can perform the task even when there's no instructions. That then means we can use this for tacit knowledge. Tacit knowledge is the sort of experience that you and I have gotten through our careers and that we get paid for. Well, AI can now do and exploit lots of that. And so as you think about opportunities for using AI, it's moving from codified knowledge to tacit knowledge. I think as you think about what's coming to the labor market that the young people are going to graduate into, you want to invest wisely in your skills. So recall, there are some jobs that are going to be automated and there are some that are impossible to be automated. You could roughly think of the skills that are definitely going to be automated, that are currently being automated, are programming and writing skills. Large language models write remarkably well, better than many people. So don't invest there, or be thoughtful about how you invest there. At the other end, there's a set of occupations that are going to be completely unaffected. They're physical labor. The problem with physical labor is we don't get paid very much for that. But the parts that AI is not yet, and I think for some time won't be particularly good at, is science and critical thinking. And so I think that's where I get to my advice, that that's where you want to be thinking about your investments, as you think about retooling for the second half of your career or what to study when you go to university. Then I just want to suggest an attitudinal change. This part of the talk is funny, but it's because I've spent a lot of time talking to workers about what they should do in the next stage of their careers. And a lot of them spend their time telling me all the things AI can't do. And there's a lot of things AI can't do. But I think that's the wrong attitude. Because if you want to be successful over the next couple of decades, your task is not to figure out what AI can't do, listing its shortcomings, but figuring out how to help AI to do it. And so people complain that AI hallucinates. It does, but there are settings within AIs that can effectively get rid of that hallucination. People complain that when you ask AI to write a memo, it will be boring and formulaic. Yes, but a good prompt can change that. You tell AI to write like Hemingway, and all of a sudden you'll have muscular prose, or write like your favorite writer. You might worry, and this is true by the way, that AI makes very simple math errors, and it does. But AI, large language models, can now talk to statistical and other programming languages like Python. Here's my favorite example of this, by the way. If you ask AI, Is 9.2 bigger or smaller than 9.11? Think about that for a moment. You know the answer, right? Many large language models will actually say that 9.11 is bigger. And the reason is they've been trained on text and they're looking at software. And version 9.11 comes after version 9.2. So that's just a simple way in which learning through natural language can lead you to make terrible math errors. As a result, you could complain about that, or you could realize actually these models have ways of succeeding despite that. And that's when you tell it, go and use Python, which doesn't have that same training to solve this problem. And it will write code and run a little program for you. Some people say that AI lacks creativity. There's actually some very good experiments on this, and they actually show that using AI can lead to better and oftentimes more creative ideas. We like to think as people that we're particularly creative, but we're not. We're not necessarily more so. And then there's the problem. Some people say that computers lack empathy, and so AI will always be terrible because it lacks empathy. First of all, you say, please answer the following with empathy. That helps. And I'll tell you the second thing. Late at night, I get tired and I get cranky. But AI never does. And so late at night, AI is going to be more reliably empathetic than I am. Again, the point here is try and figure out ways to use the technology to succeed rather than focusing on the ways that it fails. So my final piece of advice, and it's a very simple piece of advice, and I do this every day, is given the way the world is changing, what I would do is every morning open up one new tab that has ChatGPT or your favorite engine in it. And every day test drive it for one new task. 3/4 of the time you'll discover it's amazing, and 1/4 of the time you'll discover it's terrible. But the set of tasks that you can have done cheaply, at high quality, and incredibly quickly and productively will increasingly expand. The favorite that I came up with is I recently spent a couple of hours organizing a family holiday. We went to Tasmania, which is in Australia. And it turns out if you just ask a large language model, please organize a family holiday for me, it's trying to figure out what days you should go where, and that's the sort of task it's ideal at. Thank you.